Welcome to The Explainer. Today, we are going to talk about one of my favorite design patterns in Java, the builder. It's an absolutely brilliant way to create complex objects that are not only safe and solid, but also a joy to read. So let's kick things off with a question that, every single developer has to face at some point. When you're creating complex objects, how do you do it without accidentally building a house of cards that's just waiting for one subtle bug to bring the whole thing down? See, if you don't have the right blueprint from the get-go, you're pretty much guaranteed to fall into one of two classic traps. We call them the twin perils. On one side, you have confusing, unreadable constructors, and on the other, you have these dangerous, half-built objects. All right, so let's really dig into this problem. What exactly makes these old ways of doing things so risky? Let's break it down.
Okay, on one hand, you've got this telescoping constructor. It's a total nightmare for readability. You have to provide every single parameter in the exact right order. And good luck remembering if that third true was for is enabled or has cache. And on the other hand, you have the JavaBane approach with setters, which is arguably even scarier. It lets an object exist in a broken, incomplete state. There's just no guarantee it's ever put together correctly.
So, how do we fix this? Well, the solution is actually pretty elegant. It's all about fundamentally separating the process of building something from the thing you're actually building. Just imagine the builder is like a contractor on a job site. They've got the blueprint, they gather all the materials, they check everything twice, and only then do they assemble the final, perfect, and totally permanent object. Once their job is done, they disappear. And I love this analogy because it's just so perfect. You start with something flexible, something you can mold and change. That's your liquid builder. And you end up with something rock solid, permanent, and unchangeable, your ice, which is the final product. It's a beautiful state transformation. So what's the big idea here? It's that by using this helper, this separate builder object, we get to assemble everything safely behind the scenes. And then, bam! The final object is created all at once in a single atomic, guaranteed valid step. Okay, let's bust a common myth right now. The builder is not a parent of the final object. This isn't inheritance. It's not an is-a relationship, it's a uses relationship. The builder is a tool, a helper, that simply uses the product's private constructor to manufacture it. Okay, enough with the theory. Let's get our hands dirty and look at some code to see how this beautiful idea actually comes to life. So take a look at the code. You can see there are two distinct parts here, working in tandem. On one side, you've got the HTTP request itself, the product. Notice the private constructor and those final fields? That's what makes it immutable. And then you have its partner in crime, the builder, which holds all the data temporarily in its own mutable fields and provides those nice fluent setter methods. And using it just feels natural, right? It almost reads like a sentence. You just create a new builder, you chain together the properties you need, setting one after the other, and then you just call build to get that finished, unchangeable object. So clean. All right, here's a classic interview question for you. Why does that builder class have to be static? Trust me, it's not just for decoration, it is absolutely critical to how this whole thing works. Let's break it down. The logic is actually super simple when you think about it this way. You need the blueprint before you can build the house, right? You can't need a house to make a blueprint just to make the house. That's a circular dependency. Making the builder static means it exists on its own, totally independent, so it can do its job of creating an instance of the main class. And that brings us to the other key part of this whole security system. Why does the product's constructor have to be private? This is what really locks everything down and guarantees safety. It's all about control. That private constructor is like a bouncer at a club. It stops anyone from just creating an object directly with new. It forces everyone, and I mean everyone, to go through the proper channel, the build method. And that's exactly where we put all our important validation logic, ensuring no invalid object can ever be created. Okay, now we get to the real payoff, the whole reason we go through this effort. True, rock-solid immutability. That little final keyword, that's our magic wand. It guarantees that once an object is built, its state is frozen in time. It cannot change, ever. And you know what that means? It's automatically thread safe. You can pass this object around in a multi-threaded environment without any locks or synchronization. Think about how many bugs that just vaporizes. So if you remember just one thing from this whole explainer, let it be this. This is the golden rule, the entire philosophy of the builder pattern in a nutshell. Mutable while building, immutable when built. All right, so this all sounds great, but when do you actually use it in your day-to-day coding? Let's get practical and whip out the playbook. Here's a really good rule of thumb. If your class is getting complex, say it has 4 or more parameters, especially if some are optional or you need to do some validation, the builder is your best friend. But, for a simple little class with just 2 or 3 required fields, a regular constructor is probably just fine. Don't over-engineer it. So when you decide to use a builder, you've basically got 2 paths. For simple cases, you can use a library like Lombok and just slap an @builder annotation on your class. It's super fast, saves you a ton of typing. But for your really important core domain objects where you need custom validation and total control over the construction logic, yeah, you're going to want to roll up your sleeves and write that builder by hand. It gives you all the power. And this right here brings it all together. It's the entire flow from start to finish. You start with that static helper, you use those easy-to-read Fluent methods, and you end with a call to build that gives you a guaranteed, valid, and totally immutable final object. It's clean, it's safe, and it's predictable. The builder pattern isn't just about writing cleaner code. It's about how you start the story of your objects. Are they born into a world of chaos and uncertainty? Or do they begin their life with a foundation of integrity, safety, and predictability? That first chapter really matters.